Hello everybody, and welcome to Distributed Systems again. Now, as promised, I'm going to give you a brief overview of Assignment 2 and what the entities and components are. Now, feel free to use this, whatever it is that I'm going to draw here, as a basis for your sketch, but please don't use it as is. Alright, so the main entities in Assignment 2, as we found out yesterday, are the atom or aggregation server. Now, of this entity, we only have one. Now, with this atom and aggregation server or aggregation server, there are a number of content servers that are communicating. I'm going to call them CS here just because I'm lazy. Alright, so we have a number of content servers. These are more than one, clearly. They can be, I don't know, 1 to M if you must. And also, so these content servers will put stuff on the aggregation server. We also have a number of clients as well. So you have client here, and so on and so forth. Now, what the content servers do is they take input from a file here, and this is basically text. They convert this text into an XML, so maybe convert to XML, and then they put this XML file, they send it to the aggregation server. So send XML. Now, what the aggregation server does is it takes this XML and it uses it in some way. The spec will tell you how, and we're going to talk about it later. Now, what your client does is it gets the latest news feeds from the aggregation server. The aggregation server will respond to this GET request with an XML file. Now, your client will read this XML file and it will extract the text. And of course, after it extracts the text, it will print it out to the terminal. Now, here we use XML as a communication language between all of these entities. This is not the main focus of the assignment. The focus of the assignment is basically to construct all of this. Now, in terms of the XML, you can do two things. You can either write your own parser, which means that you're going to go through every line of the file, find a starting tag, and then go again through that line or through the next lines and see if you can find an ending tag, and so on and so forth. Don't do this, please, because it's very time consuming. It's going to take you a long time to get right, and by the end of it you'll end up having written only an XML parser. There are a number of Java libraries that deal with reading and printing XML, and these are either Sax or DOM, and there are plenty, billions of tutorials out there on the web as to how to do XML parsing with Java in Sax or DOM. So please have a look at those and use number 2 rather than use number 1. Okay, so now this is a basic structure of your assignment. What does need to happen in this whole thing is you need to also have, and you need to take care of failures. You need to take care of ensuring that things happen in the proper order, and you need to test your assignment. Now, with respect to failures, your aggregation server will have to implement something which is called, we call it a heartbeat, which means that basically your aggregation server will get rid of the feeds from one of the content servers if it hasn't heard from them in the last 15 seconds. Now, you can implement this in many ways, and your choice, and the choice is up to you really. For example, what you can do is you can, every 15 seconds, you can have the aggregation server ping all of the content servers to see if they're alive. or you can have the content server send a heartbeat message to the aggregation server every 15 seconds. Alternatively, you can say, I'm going to consider this XML that is sent from the content server to the aggregation server as a heartbeat. Now, again, as I said, the aggregation server will get rid of the content from a content server if it hasn't heard from it in the last 15 seconds. What you do afterwards, it's up to you, in the sense that you can replace the content that you've thrown out with content from other content servers, or you could just ignore this. It is up to you. The first solution implies, of course, that you have to keep all of the feeds from all your active content servers and then just feed to your client the latest 25. Now, with respect to the Lamport clock implementation, now here we're basically going to use Lamport clocks to order every operation that happens on the aggregation server. So in here, for example, let's say you have a number of puts from your content servers, you have a number of gets from the content servers. They all arrive at the same time in the queue at the aggregation server. The aggregation server will order these operations based on the Lamport clock. Here, you can use the get message to piggyback a Lamport clock to it. So you can change that get message in another Lamport clock. You will probably need to change the XML to include a Lamport clock as well for the client to see and to update its Lamport clock to that of the aggregation server. In this one, you might probably need to send back an acknowledgement message from the aggregation server with the Lamport clock. Taking care of failures. So there are 3 types of entities in this system, and of course that's at least 3 types of failures. We see what happens in the case the content server goes away. There's a heartbeat message here. The aggregation server will remove content. If the client goes away and comes back again, it really doesn't matter for this system. If the aggregation server goes away, then of course you have to decide what you're going to do both for the content servers and the clients. For example, for both of them, you can do a retry. So let's say you're going to try to reconnect to the aggregation server a number of X times. You can do a ping to see if everything is alive and so on. It's really up to you. You do have to implement it though. Another important thing that needs to happen for your aggregation server is, let's say your aggregation server is now alive. This is step 1. At some point it crashes. So it becomes dead. A few moments later, it comes back again and it becomes alive again. Now, at this point in time, what you might want to do is you might want to, let's say you've saved the previous feeds that the server had. You might want to read these feeds when the server comes back alive again, such that you have at least something to give to your clients. Now, of course, the connections from the content server to the aggregation server and the client connections to the aggregation server, they will all be dead and everybody else will have to reconnect using their retry mechanism. Okay, I think this covers it with respect to the general structure of this whole thing. That there is one more important advice that I have to give you, and this one is with respect to the implementation of the Atom server. Now here, when we set this assignment, we hadn't looked at Java. We hadn't looked at Java for a while, and we had thought this as a basic socket implementation, in the sense that all of the client connections, all of the content server connections will be socket connections to your aggregation server. This means, of course, that you have to set up a thread pool here at the aggregation server. You have to have a multi-threaded implementation for both the content servers and the client server connections. It's going to be tough to implement it, but it's not going to be tough. It's going to be tough to learn how to implement it. But there are zillions, billions of socket tutorials out there on the interwebs. You can also implement this whole thing using something that is called an HTTP server. Now, this has appeared since Java 1.6, and it's been released. It's been released in Java SE. What this one basically does is it manages the connections to this server automatically. So it creates the thread pools for you. All you have to do is you have to define what kind of threads are running. Now this has a much less steep learning curve. You're going to easily be able to start doing things very quickly. However, I think there are only about 2 tutorials on the web. So if you need to debug it or if you need control over the threads, you're basically stuffed. So my advice to you, use the XML parser that is already out there, use a library, use Saxo DOM. Don't use HTTP server, use sockets, and start with a simple client server, content server implementation to check that everything and everybody connects. And of course, if you have questions, email me or put them on the forums. Thank you.